Hi everybody, this is Dark Guardsman and we're back with another video. Now we're going to pick off with where we left off with the last video and kind of showing more about visualizing missile paths and everything else. Now with the last application, what we simply had was just a small little kind of box here that kind of showed the path, and we had preset some values in there to kind of get our calculations going. I've iterated on this design and implemented first a little control panel on the side to actually input stats. I'm going to be expanding this more as we go and importing more variables and more data to actually modify the calculations. On top of this, we got a little button we can actually calculate, and on the right hand side we've got some of the data. So that same data that we saw in the console with the last video, we can now see some of it, not all the data points, because the data points of course are going to visualize and render when we click calculate. But it does give us a lot of these starting values that we would have had to go through and dig through the console to get, including tells us what our max Y is and the amount of approximation of the arc length. It's not a perfect calculation because we're not using an advanced calculus function to do this. I know some people in the mod development Discord were helping me with this earlier and trying to help me figure out how we're going to do the arc length, and showed me some really cool integral calculus based functions, and I ended up just making a summation because it kind of works. But if we hit calculate, it does the same exact thing, but what it'll do over here is it'll tell us, hey, the filled for max height is 760, the flight time is 400 ticks, acceleration, which is going to be one of our factors of calculating things, but it now tells us our initial motion y, x, and the actual motion as of magnitude. So this would be like if you were pointing in a direction, this is how much motion it's going to have, or acceleration is a good way to put it too, because this is, actually it's not acceleration, it's actually velocity would be a good way to think about it. Actually, I guess exactly what it is. But we also get our max y, which tells us what this top part here actually is. And we get our approximation for arc length, which is how much distance we have traveled to get to the target. Now I can change the value up here and recalculate it, and it's going to give us pretty much the same exact shape every single time because of how it's set up the render, so we're not going to get a different render each time, but we will get different data. So it'll tell us what the max y length approximate. It'll also tell us that our acceleration starts to change differently. This is one of the things that, thanks to the software, we finally figured out kind of what acceleration looks as you change the value. When you sit with a small value, acceleration will end up with a really large value. Of course, you don't have a lot of dots going because it's a really quick travel time. You start increasing that, and you see acceleration actually modify. Same with motion as well, if you've paid attention to that. But when you start to get to really high values, these two values change dramatically. So instead of motion going up, it starts to go down because the acceleration changes. The acceleration is one of the biggest key factors in how this entire system works, because this is not an actual fully consistent projectile motion calculation. So what you would have with a projectile motion, or any kind of projectile, so this would be an arrow, cannonball, artillery shell, anything that you would blast off at an angle with a certain amount of energy, would end up with an arc like this. But the way we have this set up is it's different, because normally what you would have is you would have a starting velocity, which we do calculate by the way, but then gravity would start to take over and pull you back down. We don't actually use gravity, we use acceleration itself as the gravity constant, and the reason this is done, from the way I've reverse engineered the code, is to ensure that our starting point, which is down here on the left, and our end point on the right, actually stay consistent. So no matter what we change with any of the other values, we will always end up at the same endpoint as long as this acceleration ends up modifying it. So if we go through and we change how max height works or how the flight ticks work or whatever we change, we will always end up at the same endpoint, which is really cool about how this equation works, which tells us it's not an actual proper equation for any kind of ballistics at all. But anyways, let's continue into this and talk about this. So one of the things I was actually asked is like, why am I messing with all of this? And do I actually understand the math that's going on here? So last video I made, I actually did understand what the math did before I even made the video. When I was talking about that I didn't understand certain things, it wasn't that I didn't understand how the math functioned, because this math is pretty easy, and you can tell from the documentation that I do have a rough idea of what's going on. What was not understood was some of these magic values, like what does 160 do, what is this, why do we have a max height, how do these values play with each other? And before I made that video yesterday, I had started off with a notebook and had started writing down all of these values and started working out how the math tied to each other, how it organized, and then I was like, you know what, we're going to make a visualization piece of software, because it's too hard to picture this in my head as I'm working through the math, and I'm definitely not going to sit there and calculate through this, and doing something like Excel or something like that isn't going to get me where I want. And instead, we need a piece of software like this that can actually go, hey, this is exactly what the arc looks like, and here's how the values end up going on. Although, to be honest, the graphical part isn't as useful until you see what I've been doing with it recently. But getting back to this, really quickly, one thing I do want to point out, I did finally figure out what 160 and 3 actually do. So this is pretty much a flat scale. This scales the height linearly based on the flat distance. So if we end up changing this to any other value, it'll go up, it'll go down, depending on the scale of the value. Then 160 is just kind of an initial value. So these two values play together to actually do modify the max height, but the value of the max height variable is not actually the max height. Instead, it plays in with acceleration. Acceleration then determines the max height, simply because the velocity going forward, you'll eventually get to a point where your y velocity will hit 0, and that's where your max height will actually be. And we could calculate what the max height is based off of this, and we did a lot about math. We also kind of figured out what some of the missile flight time is. So basically what we're saying with the missile flight time is that effectively we're going to take 2 ticks to travel 1 meter flat distance. So if we're going to go 100 meters, we're going to end up taking 200 ticks, which is going to be 10 seconds. And of course we have the tick and error, which is minusing out of this because at any time you can recalculate path. The homing missile does this continuously in order to make sure that it actually ends up at the right target destination. And of course, if you had to recalculate, say for example, we fired the missile out of the tube and it took 10 seconds to get out of the tube instead of the normal like 2 ticks, you would want to of course modify this because the missile flight time would not be consistent, and then that would have clearly modified your acceleration, or you'll not hit the same target. So we have figured out a lot of these variables, but what I wanted to really do with the visualization software, and this is what I want to show off what I've been working on, because I rewrote the application completely again since last video, cleaned it up a lot, and one of the things I actually worked on, and let me go ahead and comment this back in, is that I actually have been toying around with visualizing multiple arcs based on different values. So we have the calculation code down here, and it ended up evolving over time. We actually have the arc length down here, which is calculated. It's a very simple sum function. I was told I probably should be using an integral function for this, but I really don't care. Summation works. It gets me really close, and from what I've been able to do with rough approximation math by just doing basically 1.5 times what the triangle would be, I know it's really close. It wouldn't be very good to use this for a mathematical problem and actually go, this is exactly how far the arc travels, because it's not precise, but it does tell me roughly where everything's going. And of course we do have the max y down here as well, which is really useful because I can figure out where it is without looking through the data. Because if we look through the debug data, and if we're doing really long calculations, like say for example we set this to 100,000 and hit calculate, not only does it take a while to calculate, it'll kind of freeze up the application and eventually give us the result. Then if we wanted to come down here and actually look at the max y, and if it's actually, no, we're actually running the run one. So we're running the run one, so we have 200,000 data points basically to go through. And if I wanted to sit here and scroll up here, I'd be scrolling up all day, so it's really nice to actually have that now in the application. But some of the parts I wanted to show off here is that I have been modifying the function here. So I've actually set it up so I can change the height in it and change the scale up here with a method call and actually look at that. And it creates a lot of really beautiful graphs now. So I'm going to show this one right here where we're modifying the height in it to see how the height in it actually plays and modifies the graph. So if I now change this, and we're not going to set this to 100,000 because my computer might literally crash if we do too high. We're going to say we'll do 100 because then I'll calculate pretty quick. And actually, hold on, I need to restart the application. And let's turn this into debug mode. That way we can actively change the code runtime. A really cool thing about this function is that, one, we're going to end up with 10 arcs. And each arc is going to be randomized color-wise. And of course, it's going to be 50 a nit off from it. So we're going to end up with, basically at the end, about not quite 500. It'll be 950 will be the final init height value. Now let's go ahead and set this to 100. And let's full screen it and calculate. And if you saw on the side, you will see a whole bunch of flashing over here because it is going to calculate each individual one. We don't actually store the data per arc here. I will probably come in later and work on it more. But what we can see is really beautifully a whole bunch of these different graphs, and we can see how this works. So for every 50 we go up, you can see it actually modifies the arc heights and the maximum y we hit by a decent amount. Now I don't have actual data to say exactly what that translates into, so for every 50 meters what does that turn into y value, but we know at the top of this is about 189, and well, we could probably write some graphics to figure out what the height value is for each one of these. I'll probably make another video later when I actually come through here and really beautify this software. And there's very likely when I finish this, what's going to happen is I'm going to package this by itself, and you guys can actually sit here and use this to play around with and toy around with what settings you want to do, because after all, when I get this math done, one of the end goals, like I said in the last video, was to allow you guys to customize your mod packs to control how this works and control how your missile flight works. So what you could do is pull the software out and go, I want to increase the speed by 2 and then change the max height by like 100 or something. And you could actually see what that looks like, and you can compare it to the default values and everything else. and of course look through all the data and check it yourself. And there's a lot of other things we'll probably do with this. Like later on, I really hope to take the knowledge I use from this and go take it over the rewrite of ICBM and play around with it, but also in the classic version itself, allow you to, as a player, to control some of this stuff. So say the mod pack developer enables some settings, so we'll probably might turn this off by default, but if you enable some setting, then what you can end up doing is actually changing your arc length, and you can have missiles that all fire from the same destination, but all land on the same destination, but then are at different elevations. Because elevation would be really, really useful to, evade anti-air. Say, like, if this was down here at 100, AAA would be really easy, because usually, I think I set the AA guns to, like, 250s where they end up shooting at. So having your missile fly at, say, like, 2,000 would then avoid most AA guns, which would be really, really useful. Anyways, let's play around with this more. So one of the things I've actually been doing, and I've been showing this off in Discord, is actually posting tons and tons of graphs with all the different data showing off how this works. And we can actually do that as well. And oh, wrong button. It was easily to say I have not scripted this, and I have a ton of windows open at the bottom. But let's say we take this to 100, and we're going to generate 100 different values. We can then come back in here and hit calculate again, and we should get a ton of different stuff. And it creates some pretty wacky looking graphs when you sit here and toy with it and do a lot of other stuff. Especially if we sit here and we take this up to 1,000, it'll turn into solid lines. Of course, it takes a lot of time to calculate. We can see the numbers sitting here rolling over here, approximate arc length, everything else, and we get a ton of nice, beautiful rainbows of death, is like how I like to call this, because you got to keep in mind that these are missile travel, and it looks pretty, but those would kill you. One of the things we can also do with this is we can not just visualize the init height, but I can come down here and through and say, okay, instead of visualizing this, I'm going to set this back to the default of 160, and now I want to visualize what the height scale does. And we'll get completely different values. Of course, it's going to visualize probably roughly the same, because I haven't designed this to actually have any kind of graphical scales. For those of you who pay attention in math class in elementary school, you know that without a kind of little key on the side to tell you what these are, the data is not very useful to actually calculate much off, but it does give us a visual information to actually look at. So let's make sure this actually reloaded by hitting Alt R. And we can then hit calculate again. And we can actually see what this looks like. So we can see, like, if you set the arc to 0 on that scale, your missile pretty much flies straight. I'm going to guess that bottom one down there probably is only 10 feet off the ground, which is kind of useful. We could use this for cruise missiles in the future by knowing this. But you can see that that scale has a dramatic effect on the actual arc length of these missiles, is that you actually end up with pretty heavy spacing and pretty different arc lengths. We probably could measure the degree between these. Like this one down here is probably only like 5 degrees. This one's probably like 15, 45, maybe 75, so on and so on. With the final one end up probably arcing like 120 degrees or something like that. I don't have a protractor on hand, so this is really a guess, but it's pretty good information to know. And of course, we probably could even do other things with this. One of the other really cool things we could do with this is just this little function that we've added here. Let's say we wanted to play around with the trajectory as well. So I can say, okay, I want to see what missile flights look like by adding 100 each, and of course we set this back to the default 3, and I want to see what they look like by spacing them out. And we get this reloaded, hit calculate again, and we can actually watch what happens when we it's actually, I think his graph is actually reversed, but it gives us information to actually look at, and we can actually see what this would look like. And it's actually surprising that this is the first time I've actually tested this. This graph is completely inverted, which is hilarious, but it's still kind of good to know, is that this is our start point, this is the end point over here, but we can see the trajectories and everything else. So really cool visualization of information, and this would be something that inside Minecraft yourself you wouldn't be able to test precisely, which is why I spent a lot of time working on tools like this, is that you would normally in Minecraft have to pretty much fire millions of missiles and watch each one and then get a mental picture of what's going on, and the mental picture wouldn't still tell you much. Instead, you can write a piece of software to do visualization. This is kind of how professional game developers actually end up doing stuff. This is where I've actually learned this from, is I'm taking a class on business analytics right now, where as a business analyst, what you would end up doing is taking a whole bunch of data and graphing it visually like this to actually figure out what that data is telling you. In this case, we're taking data points of missile travel path, and we're visualizing it to actually look at what's going on. And even though you wouldn't find a business that actually did missiles outside the Army, actually the Army probably would use something like this in order to calculate paths. But I'm going to leave it there, and I'll come back with another video talking about this more, but it's all I really got, so